Page 114. Graph each system by hand, meaning we're not using Desmos. And I gave you the graph paper. What I'd like you to do with the graph paper is to fold it into fourths. Do you remember how we did this the other time? And we glued one of the fourths down and then folded the paper up. Now, if you want to just glue it directly on the page, on page 115, you can, or you can glue this 1/4 down on page 114 or 115. I don't care. Okay? However you want to do it. All right. So in our system of equations, we have two equations. What kind of equation is this first one? X squared plus 1. What kind of an equation is that?
Isn't that the,
Yeah, quadratic. Wow, you guys go to prom? No. Quadratic equation, yes. What about the second one? Is that a quadratic too? It's a what? Standard. What do you mean by standard? Okay. What kind of equation is this one? Y equals 4x plus 1. Is it quadratic? No. Think about the graph. What would the graph make? It's linear. A linear equation, meaning the exponent is to the first power. Okay? So we are going to be graphing both of these. Let's start with the linear one. 4x plus 1. Now, try to remember, because I know it's been a while, what form do we want to have a linear equation in so we can graph it? Is it in a good form now? Yeah. Does anybody recall what that's called? Very good. Slope-intercept form, which means we should be able to get the y-intercept and the slope from that form. So what is my y-intercept? And if you recall, it's y equals mx plus b. What is my intercept? 1. So this right here is your y-intercept, which means 1 is my y-intercept. And what is the slope? 4. That's the m, which is the 4 here, which is 4 over 1, which is up 4 and to the right 1. So from that point of my y-intercept, I go up 4, 1, 2, 3, 4, over 1. From that point, I go up 4, 1, 2, 3, 4, over 1. Try to find some kind of a straight edge, maybe one of the calculators or something. And, oh, that's really bad. But you get the idea. Okay, so that is the graph of that linear equation. 1 down, 1 to go for this graph. Also, before I forget, you may want to put on or around that first graph the two equations. So either above them or below them, just so you know what you're talking about. So y equals x squared plus 1, which I should have done in a different color, and y equals 4x plus 1. I'm going to change mine. Okay. Y, oh, it's still blue. Hello. Y equals x squared plus 1. Okay, so now we're going to graph our parabola on the same graph. Oops. Jeez. Crazy. So, I have this y equals x squared plus 1. What form is that written in? What forms do we even have for quadratics? This is kind of a good review because I'm going to be asking you questions about these. So x squared plus 1, what kind of form is that in? Yeah, it's kind of pretty much in standard, right? So we have standard form. What are the other two? Vertex form. What was the last one? Factored form. It's definitely not in factored form. Could almost say it is vertex form too. But it is in standard form. Okay? If something is in standard form, do you recall how we can find the y-intercept? Okay. Think about it. Think about any point that is a y-intercept. I'm going to sit down. Think about any point that is a y-intercept. Where's it going to fall on? What's it going to be on? The y-axis. So any point that is on the y-axis, what do they all have in common? Where? No, you're right. Where at? For what? Yeah, x is 0. So anytime you have a y-intercept, okay, let me put this down. Anytime you have a y-intercept, that means that x is equal to 0. So if x is equal to 0 and I substitute 0 into that equation, what is my y-intercept of that? What is the y-intercept if I substitute 0 in for x? What do I get? No. When I substitute 0 right here in for x, what do I get from my y-coordinate or my y-intercept? 1. 0 squared is 0. 0 plus 1 is 1. So y is equal to 1. All that's telling me is that is the y-intercept. So I think what we have talked about before is that when you are in standard form, the C value is going to be your y-intercept. That's really the big thing that standard form helps us with, okay? Is that the C value is the y-intercept, okay? Because the first two terms are going to zero out. Now, there's no bx here, which means that b must have been 0 to begin with, okay? How could I change this from standard form into either vertex form or factored form? Actually, vertex form isn't going to be very helpful. How could I change it to factored form? Because you're going to have to know how to do that on the test. How to change from one form to another. So how would I change this from standard form to factored form? How do you factor? You've done that before.
If you made it into factor form, would it be x plus 1, x minus 1?
No. That is a difference of two squares, and this is not showing a difference. So you're close. If it said x squared minus 1, that would work.
So would it be the greatest common factor?
Yes. You need to look and ask yourself, do I have a greatest common factor? That's what you always ask yourself first. Well, after setting it equal to 0, but yeah, we're looking at this side. So do I have a greatest common factor? No, I don't. Okay, what do we do next? Xbox. Before I do Xbox, I have to know what goes in the X's. So I need to find A, B, and C, right? So what is my A value? No. Your A, B, and C are always digits, always numbers. 1, right? It's the coefficient in front. What's my B value? No. 0. Yeah, I don't have a B value. There's nothing X here. And what's my C value? 1. So, this is kind of interesting. A times C goes at the top. So that's 1 times 1 is 1 and 0. So, factors of 1 that add to 0. Factors of 1 that add to 0. It doesn't really make sense, does it? Factors of 1 that add to 0. Why does that not work?
What did it just be? Literally 1 and 0 again? The formula that would work.
Well, 1 times 0 doesn't not give you 1 though. Usually, why is it not negative? Usually you think 1 and negative 1, which gives you the 0, but 1 times negative 1 does not give you a positive 1 here. I don't know why this is not working out. Do you see something I've done wrong? A is definitely, there's no negative here that I missed, right? No. So it's 1 for A. B is 0. There's nothing there. C is 1. That is weird. A times C. 1 times 1 is 1. B is 0. Almost all the time they're negative. Okay, well we can tell factored form is not working well for this one either. Okay. Vertex form is going to be pretty much the same. I really don't know why that's not working out. I'm going to have to ask another teacher about that. That is weird. All right, so let's go, or no, that was factored form. Vertex form isn't going to be much better because we know vertex form is like x minus whatever your h value is for your vertex plus k. So this is my k value, and this is squared. So x minus what gives me x squared? 0, which means my vertex is 0, 1, which we already have. All right, so that's my vertex. We knew it was the y-intercept, but now we know it's the vertex also. So, okay, let's go back to some basics. Is this parabola going to open upward or downward? And how can we tell? Upwards. How can we tell? A is positive, no negative out front. So we know it's opening upward, so keep that in mind. Well, shoot, what else can we do, Miss Thede? Well, let's think. What shape is this going to be? A parabola, right? So if you're looking at a parabola and that's the vertex, we know it's going up. We could just do a table of values, couldn't we? We know y is x squared plus 1. And what values would I want to look at? What might I want to put x as to check and see what the y value is? Probably on either side of your vertex, right? Maybe one space to the right, 2 spaces to the right, and then 1 space to the left, and 2 spaces to the left. I know that's backwards for you guys. So to the right, let's put in 1. If x is 1 and I substitute 1 in here, what's my y coordinate, my y value? It's 2. So 1, 2. 1, 2. There's a point. So if you get stuck, just do some values from a table, okay? All right. What else would be a good x value to do? 2. 2 squared is 4. 4 plus 1 is 5. So 2, 5. Now, we could go and do 3. Usually I kind of like 5 points. Well, we have basically the right-hand side, and we know parabolas are what? What's that word? Where they look the same on both sides? Kind of symmetric, right? They are symmetric. So if I wanted to put in -1 without calculating it, what do you think the y coordinate would be? It should be 2, right? It should be the same as what's on the other side. And if you put that in, -1 squared is 1. 1 plus 1 is 2. And same for -2. If you put -2 in, it should be 5. And when you do that, it does work out. Okay? So graphing these systems of equations, this is what we come up with. In this particular one, our solution, which it doesn't even ask us for a solution, but our solution would be where they intersect. Okay, so your solution is definitely going to be 0, 1, and I can't really tell. I'm guessing it's going to be 3 something. Let's see. 3 squared would be 310. So technically that should go out just a little bit more. And does 3 and 10 work here? No, it doesn't. So there would be another solution. Okay? But it looks like it's going to be not exact. All right. It says also solve without graphing to double check your answer. So I want to make sure you know how to do that too. There's a lot in this simple problem. So how would I check this? How would I check this? Also solve without graphing to double check your answer. If y is equal to x squared plus 1 and y is equal to 4x plus 1, how would I check it? Any ideas? Yeah, you would. You would set them equal to each other. So x squared plus 1 is equal to y, and y is also 4x plus 1. So how would I do this to solve? Okay, subtract 1. Can do that. So I get x squared equals 4x. Now what? If I square it on one side, I have to square it on the other, and that's going to give me x to the square root. Square root? Not quite, because we have x's on both sides. So we need to get our x's all to one side, right? Set it equal to 0.
Divide,
Not,
subtract the x
no. We should subtract 4x, or that's what I would do, and get them all on the same side. So if I subtract, I'm going to get x squared minus 4x equals 0, right? We kind of do want to set it equal to 0. Now what would you do? Think if you were factoring again, what would you do? What, do I have a greatest common factor here? Yes, I do. What is it? No, not 2. X. X is common to this term and this term. So when I factor out x or divide it by x, I get x minus 4 equals 0. This is a factor and this is a factor. This tells me x is equal to 0 is going to be one of my solutions, and x minus 4 equals 0. Add 4, x is equal to 4. So at x equals 0, if you would substitute 0 back in for both of these, you're going to get 1 and 1. So 0, 1, that is one clear solution. If x is equal to 4, substitute 4 in for x, and we get 4 squared plus 1. 16 plus 1 is 17, and 4 times 4 plus 1 is 17. So when x is 4, y would be 17. So it's even higher, goes out a little bit higher. So solutions will be 0, 1, and 4, 17. Technically, they weren't asking for that, but it does say solve without graphing to double check. Okay? Any questions on that one? How's your brains right now? A little tired already from one problem? The biggest thing about these, I think, which is sometimes confusing, is that there are several ways you can solve these. Okay? Which makes it like, why isn't there just one way? Which can be a good thing or which can be a not so good thing. Okay? All right. Well, let's leave this one. Let's go to the second one. It says we have two equations. Y minus x equals -1. Y equals x squared minus 6x plus 9. All right, let's graph the linear one first. Which one is the linear one? The first one. So on your graph somewhere, you might want to rewrite them. Either at the top or the bottom, someplace. All right, so y minus x equals -1. Is that in slope-intercept form? It is not. What would I do to change it to slope-intercept form? And how would I do that? How would I change this to slope-intercept form? Do you remember what slope-intercept form is?
Don't you add the lines to both sides?
Add x to both sides. So x's will cancel out. I get y equals positive x minus 1. Is that in slope-intercept form? Yes. What is my y-intercept? -1, yes. So a dot goes at -1. This is your y-intercept. And what about my slope? What is my slope here? It's not x.
0.
It's not 0. According to this, it has to come in front of x. It's 1. This is 1 understood. So that means my slope is 1 over 1, which means 1 up and 1 to the right. So starting at that y-intercept, up 1 over 1, up 1 over 1, up 1 over 1. So it's on the diagonal of each of those boxes, those squares. So connecting those, that is your graph. Y minus x equals -1. Okay. I'm going to erase this to help us get prepared for the next one, which is a quadratic. What form is that in right there? Standard form, yes. This is a quadratic equation. This is in standard form. And standard form, what good is standard form? What does that help us do? Not a ton, but a little. Okay, we can say it equals 0. What else? We just talked about this. The C value is your what? Yes, it is the y-intercept. Because if I substitute x is 0, these are going to cancel out, and I'm left with 9. So I can tell here that C is 9, and that is my y-intercept. So 9, y-intercept. Not fantastically helpful, but it's a point, okay? What about, does this open up or down as a parabola? Yeah, because A is equal to 1. Shoot, we might as well do B. B is -6. So I know it opens upward. Okay, so I have it right now in standard form. What could we do to maybe change it into another form that might be helpful? What? Okay, so let's say if I want to go to factored form, how do I figure out what my factors are? If we have a quadratic, okay, yeah, you're going to do that. You're going to do X box probably, right? So do I have a GCF? What is it? Well, there's nothing, 1 divided by 3, that's just a fraction. So it's not going to be 3. So do I have a greatest common factor? No, we do not. So now I do have my A, my B, and my C. Let's go to the X box. A times C is 9, and B at the bottom is -6. So what are 2 factors of +9 that add up to -6? negative 3, and negative 3. So when I put in my box, first term goes in the first box. Last term goes in the last box. And the middle two are these numbers that we found. Negative 3 with an x and negative 3 with an x, because those two added together give you your b term. All right, now what do I do? Greatest common factor. So you look at each row, x squared negative 3x has a greatest common factor of x for that first one. That's okay. And for the next one, it does have that negative 3. How about the column? X squared and negative 3x is x. And how about this column? Negative 3x and 9? Negative 3. So my factored form is y equals x minus 3 times x minus 3. And if I set that equal to 0, I am getting a double root. And so if I say x minus 3 equals 0, then x must be 3. So that is my root. It is a double root. What does that mean? What is a double root? Why is this so hard? They do, because it's x minus 3 times x minus 3. So we call that a double root. So when x is 3, it's a root, so my y must be 0. And what else do we know about that? If it's a double root, that means it's going to bounce off. Okay, so that also means, besides it being my root, it is also my vertex. Okay, it's called a double root. It's going to bounce off, hit the x-axis and bounce off. Okay, so there's that. Well, vertex form isn't going to help me because we already have our vertex form. We already did standard and we got factored, but we need a few more points. So what should I do? Gonna have to use a table. But I do have, that's my vertex. So if I have x's and y's, I want to see what's happening 2 places to the right and 2 places to the left of that vertex. Just to check, okay? So what would be a good x value that I would want to find? So, okay, 5. And y, now I got to put all this in. So that's x squared minus 6x plus 9. So when I put 5 in, I get 5 squared minus 6 times 5 is 30 plus 9. 25 minus 30 is negative 5 plus 9 is 4. So that means for 5, it's going to be 4. So 5 is my x value, 4 is my y value. What else would be a good value to check? Huh? Yeah?
Is that a plus 9?
Yes, that is a plus 9.
7.
Ooh.
Too far?
I mean, we could. I just usually like to see 1 step to the right, 2 steps to the right, 1 step to the left, 2 steps to the left of vertex. So how about 4? So then that gives me 4 squared minus 6 times 4 is 24 plus 9. 4 squared is 16. 16 minus 24 is negative 8. And negative 8 plus 9 is 1. So that means I'm looking at 4, 1. Well, that's just right there. And we just said this is going to be symmetric, right? So if 4 is 1, what do we think 2 is going to be? 1. Now let's just check it. So put in 2 for x. 2 squared is 4. Minus 6 times 2 is 12 plus 9. 4 minus 12 is negative 8 plus 9 is 1. Oh, good. That works out. And what do we think I'm going to get for a value of x equals 1? Without calculating it. No. Here's 1. Here's my vertex. Should be 4, right? Right? So it should be 4. So I'm going to say 1 squared minus 6 times 1 is 6 plus 9. 1 minus 6 is, oh my God, I can't think. Negative 5 plus 9 is 4.
Wait, so did you mean to put that 9 over there?
Yeah, that was my y-intercept that we found when we put 0 there. So let me ask you a question. What's going to be the y-intercept, or not y-intercept, y-coordinate when x is 6? No. They're symmetric. Should be 9, right? Right? Okay. So we talked about a lot of stuff there. I forget, 223. Really quickly. And I am recording this so you could look back at it if you want. What do we call this line right here? Yes, very good. The axis of symmetry. It always sounds sinister to me. If you want to find where your vertex is, you need to find the axis of symmetry. Axis of symmetry, you may or may not recall, is opposite of B divided by 2A. This is important. That might come in handy on the test. Again, there are many ways to do these problems. Now, axis of symmetry. My A was 1. My B was negative 6. My C was 9. Let's see if this works. If B is negative 6 and I want the opposite of B, that's going to be 6 divided by 2 times 1, which is 3. Is this the line x equals 3? Yes, it is. So that means my vertex, if I had to find my vertex would be opposite of B divided by 2A. That's the x coordinate of my vertex. And once I have that, I can substitute that in to find my y. So this is your vertex. There you go. Saved by the bell.